Hello guys, so this is lecture number 8 on JEE concepts, and from this video onwards we are going to start the questions on Newton's laws that we have already studied in the previous two videos. So this video and some more future videos are going to be only about questions. So many questions that each and every concepts that we have already studied is going to be crystal clear after thoroughly attempting these questions and doing these questions. So let us begin with this questions on Newton's laws first. So the first question is, find the reading of the spring balance shown in figure. This is actually the spring balance. The elevator is going up with an acceleration of g upon 10. That's already given. This is an elevator actually, and this is going up with an acceleration of g upon 10. This small g is acceleration due to gravity, that is 9.81 meters per second square. And the pulley and this string are light. Like this pulley and this strings are light, and the pulley is smooth also. So we have already discussed what these things are given basically. Well, these things depicts whatever the tension will be in this string is going to be the same throughout the string, because the pulley is light and these strings are also light and the pulley is smooth too, no any friction. So the tension like this T and this will also be T. The tensions will be same here, and the mass is already given, that is this is 3 kg and this is 1.5 kg. This is heavier, like 3 kg is heavier than 1.5 kg. So this system is having a tendency to move in this direction and this in this direction. Like this 3 kg mass will move in this direction and this 1.5 kg mass will move in the upper direction as shown here. Actually, this question is asking about the reading of the spring balance, like what the spring balance is going to show. So for that, this spring balance is basically connected to the system at this point. Okay, so we need to find the force at this point, because that's what the spring balance is going to show. So here, if this is T and this is T, as we are assuming we have to find this T, then here it will be 2T. Why? Because in this case, this pulley is the system. This pulley is the system. And let me show the forces on this pulley. We have already identified the system, step 1. Now we need to relocate the forces. So this is T, this is T. So this will be, say, F. Then this pulley is massless, that is M is equal to 0. So F must be equal to T plus of T, that is equal to 2T. So this F must be equal to 2T. So we need to find this T, then we need to multiply this T with 2 to get the answer, and that is what the reading the spring balance will show. So we have set up the question. Now let us move. The concepts that which we are going to follow is the first one. This acceleration is given. Like this whole system was moving upward with an acceleration of g upon 10. So this is an acceleration with respect to some observer on Earth, that is an inertial frame. So this frame is basically what? Non-inertial, because it is accelerating, as I have already discussed. This is an accelerating frame which is also non-inertial frame. And that's why, according to the observer, which will be inside this non-inertial frame, we need to have a pseudo force on the system, and the system that we are going to choose differs. So on each and every system you have to apply this pseudo force, which will be mass of the system multiplied by acceleration in the opposite direction. Like lift is moving in the upward direction, so we need to give a force in this direction, pseudo force M into A. Similarly on this system, M into A, like this. So this is the first concept. The second concept is, you need to choose systems accordingly. When you are dealing with this 3 kg mass, then you have to choose this 3 kg mass as the system. And when you are dealing with 1.5 kg mass, then you have to choose this 1.5 kg mass as the system. And similarly, we have chosen here pulley as the system. So you can see over here that systems are going to be different. And we have already studied the 4 steps. First, choose the system, then locate the forces, free body diagram, and then equations and axis. So axis we have to choose in the beginning, or it is already clear that axis in the horizontal right direction is X and in the vertical upward direction is Y. So these are the concepts that we need to apply over here. So let us first consider this 3 kg mass as the system, this one. Now for this whole system, for this whole arrangement, I have already discussed that this 3 kg is heavier. That's why this will go downward and this 1.5 kg is lighter, so this will go up. So let us take that the acceleration of going upward, this one will be A. Then this acceleration of 3 kg mass going downward will also be A. Why? Because the length of the string is going to be the constant. This length of the string is not going to change. That's why this acceleration is going to be the same. So now locating the forces on this 3 kg mass will be this 3g, the M into G, force of gravity, and the second one is pseudo force. That will be 3 multiplied by g upon 10. and in the upward direction we have tension, that is capital T. So these three are the forces on this 3 kg mass. Similarly on 1.5 kg mass, we are having this 1.5 g plus of m into g by 10. Here m is 3 upon 2. So 3 upon 2 g by 10. That is multiplication. And in the upward direction, we have capital T. Now writing for 3 kg mass, it is moving downward with acceleration a and it is moving upward with acceleration a. So writing the Newton's second law of motion, it will be 3 plus of 3g upon 10 minus of tension T, that is equal to mass, that is 3 kg multiplied by a, that is the acceleration. This is the first equation, and second equation will be for this 1.5 kg mass, and that will be in the upward direction T minus of 3 by 2 g minus of 3 by 2 multiplied by g upon 10, that will be equal to 3 by 2 multiplied by a. That is the equation number 2, and this was the equation number 1. Now we need to solve these equations to get the tension, and then we need to multiply that tension with 2 to get the reading of the spring balance. So let me solve these equations. So this will be what? 3g multiplied by 11 upon 10 minus of t is equal to 3a. The first one, like this one. And the second one will be t minus of 3 upon 2g multiplied by 11 upon 10, that is equal to 3 upon 2a. So I can take this 2 to this side, then it will become 2t minus of 3g multiplied by 11 upon 10 is equal to 3a. Now let us add these two equations. Then this term and this term will get cancelled and 2t minus of t will be t, that is equal to 6a. So tension is equal to 6a. Now putting this value of t over here, then we will get 3g multiplied by 11 upon 10 minus of 6a is equal to 3a, that is 3g multiplied by 11 upon 10 is equal to 9a. Now there is just maths and you need to be good at it in order to not commit any mistake. So from here this 3 times 3 will be 9. So a will be equal to what? 11g upon 30. Now putting this value of a over here, we will get t is equal to 6 multiplied by 11g upon 30. So this 6 times 5 will be 30, that is equal to 11g upon 5. This is t. We need to multiply it with 2 to get 2t, and that is the answer. So the answer is basically what? 2t is equal to 22g upon 5. And we need to find the mass, because spring balance is going to show the mass and we are having this weight. This is a force. So we need to divide it with small g. So this small g got cancelled. Now we are only left with 22 upon 5. So this 22 upon 5 is the mass shown by the spring balance, and that is equal to 4.4 kg. And that is going to be the answer for this question. Now let us move towards the next question. Well, the next question is, like the force of buoyancy exerted by the atmosphere on a balloon is B. Let us take a balloon like this. Now the force of buoyancy will always act. Here it is already given that in the upward direction. Okay, so let us not take care about those things. This is B. This is a force basically, and remains constant. This is a constant force. Now the force of air resistance on the balloon acts opposite to the direction of velocity and is proportional to it. Like force of resistance is proportional to this velocity and always acts opposite to the direction of motion. And the balloon carries a mass m and is found to fall down near the earth's surface. Okay, it is like falling like this down. So the force will be like, this is mg and this is going down. Okay, so resistance force will be like this, Fr say, that will be equal to say k into v. K is a constant, proportionality constant, into v, that is velocity. And with a constant velocity, it is already given that constant velocity is small v. So this is the force. Now how much mass should be removed from the balloon so that it may rise with a constant velocity v? Okay, at the current state it is moving down. So let us write the force for this current state. We have already chosen the system as this balloon, first step. Second, we have already located the forces. Third step, FBD, we have already drawn. Now let us write the equations. So this Fr plus of B must be equal to mg, because it is moving down with a constant velocity v. So the net force must be equal to 0 according to the Newton's first law of motion. That is, without any external force, the system will either be at rest or move with a constant velocity. So the force must be 0. Net force on the system must be 0 in this case, because it is moving downward with a constant velocity initially. The next thing is we need to make this balloon rise. And for that, we need to remove some mass from the balloon. And that's what this question asked, that how much mass should be removed from the balloon. So what will happen? Basically, let me write first this. This will be kV plus of B is equal to mg. This is our first equation. Okay, this is K. After that, we need to remove some mass from the balloon according to the question. Now what will happen if I remove some mass from the balloon? The new downward force will be m minus of m into g. Let us consider this. We have removed this small m mass. Okay, this much mass is removed. Because of this removal of mass, the net force is going to increase in this direction, in the upward direction, and that's why this balloon is going to move now in the upward direction, but it needs to move with a constant velocity. And how is this going to move with a constant velocity? Well, there is another force, this resistance, force of resistance, because of the movement in a particular direction, like opposite to the movement in a particular direction. So now this Fr force will going to act in this direction, Fr. That will be equal to K into V only, because again the same velocity, this V and this V. So now a net force increased in this direction and also in the downward direction. So in both the directions, net force got increased because of the removal of some mass from this balloon. So the new equation will be, again the new equation will have the same force in both the directions because it is again moving with a constant velocity. So just we have to equate the forces in both the directions now. So in the upward direction the force is B only, and in the downward direction now the force will be m minus of mg plus of kv. So this is the equation number 2. Now we need to find the small m from these two equations. So these are the two equations basically. So let us write the value of this kv because we need to find the small m. Yeah, so from here kv is nothing but mg minus of b. Let us put this over here. Then b is equal to mg minus of b plus of mg minus of mg, like this. So this will be what? 2b minus of 2mg upon small g, that is equal to m. This will be actually minus m. So m will be equal to what? 2mg minus of 2b upon small g, that is equal to 2 into m minus of b upon g, that will be equal to small m, and that is the answer. So this is how you need to think. See, the question is very simple, but it's given in somewhat complicated manner. It is given that initially the balloon is going down but with a constant velocity, and the forces are buoyancy force, air resistance, and its own mass. Now, because of this constant velocity, the forces are balanced in both the direction. And in the second case, if you're going to remove the mass from the balloon, then the balloon will start rising, like starts moving in the upward direction. So the force of resistance direction is going to change. And because of that direction, the distribution of force is going to change. But the net force again in this case is going to be 0. And that's why in the second case also the balloon is moving with a constant velocity but in the opposite direction. So this is a very good question for you to understand. Like the case, like the situation, you need to read it very carefully. You need to understand it very carefully. Just read it once again and try to solve yourself. Okay, this is actually 4 questions, A, B, C and D. So the question is in a simple Atwood machine. This kind of system is called as Atwood machine, having a pulley and these masses and these massless strings and massless pulley, frictionless pulley, like that. So 2 unequal masses, 300 gram and 600 gram. Obviously just by seeing the question you can guess which one will be 600 grams and which one will be 300 grams. This one will be 600 grams heavier, this one will be 300 grams lighter. Are connected by a string going over a clamped light smooth pulley. The system is released from rest. U is equal to 0 in every case. That this question is going to be asking. Now find the distance traveled by the first block in the first 2 seconds. Actually in the diagram in H.C.Verma book, this is the first block and this is the second block. Okay, so we need to find the distance traveled by the first block in the first 2 seconds. So let us have this first block as the system. Before that, just like in the first question, I told you that if the strings are massless, pulley is massless, smooth, then the tension is going to be the same. This T is going to be the same throughout the string. So let us write the force balance for the first system, first mass system, because the question is about the first mass system now. And again in this case also, this whole system is going to move with a constant acceleration, one acceleration, because the length of string is constant. So this is heavier, it will be something like this A. This is lighter, this will be something like this A. So these things you need to understand inside your mind just by practicing a lot of questions. So let us write the first system, force balance. This will be 300 grams multiplied by small g, that is acceleration due to gravity. Don't confuse with this g and this g. This is acceleration due to gravity, okay? In the exam also, don't confuse this g with small g, acceleration due to gravity, okay? So this is 300 g in the downward direction, and this is capital T, okay? For the second one, this will be 600 g, and this will be capital T. So for this, the equation will be T minus of 300 g is equal to m into a, and for this 600 g minus of t is equal to 600 a. So this is first equation and this is second equation. Adding these two equations, 600 g minus of 300 g is equal to 600 plus 300, that is 900 a. So this is 300 g upon 900 is equal to a. So this is what 3 times 3 is 9. A is equal to what? G upon 3. That is the acceleration. G upon 3. This is what? G upon 3. Now we already know the acceleration. That is A is equal to G upon 3. Initial velocity is 0. That is already given. And the time is 2 seconds. Because we have to find in the first 2 seconds the distance traveled by the first block. So now applying the Newton's equation of motion. X, in this case y, is equal to ut plus of half at square. This will be 0 because u is 0. So y is equal to half a is g upon 3 multiplied by 2 square is 4. So this is 2. That is equal to 2g upon 3. G is what? 9.8 upon 3. That will be equal to 6.5 meters approximately. So that is the answer for the first question, question number A. The second one is find the tension in the string. We need to find the T. For that, let me write again for the first system. T minus of 300g will be equal to 300a. Now this a we know now, that is g by 3. So T is equal to what? 300g to 1 plus 1 by 3, that is 4 by 3. That will be equal to, this is actually in grams, so let me write it in kg. 0.3 multiplied by 4 upon 3 g. So this will be 0.1, that is equal to 0.4 g. That is T. So if I write 0.4 multiplied by 10, that will be approximately equal to 4 Newton, or will come around 3.9 Newton. That is going to be the T, tension. That is the answer for the second question. Now the third question is find the force exerted by the clamp on the pulley. Clamp is over here. So we need to find the force like this or like this. So this is T, this is T, this will be 2T. When you take the pulley as a system, I have already told. This TT and this 2T. Like TT and this will be 2T. Because this pulley is massless. So we need to find 2T. So we have already found T as 3.9 Newton. So 2T will be equal to 7.8 Newton approximately. That will be the answer. That is the force exerted by the clamp on the pulley. Now the last question. Like the larger mass is stopped for a moment 2 seconds after the system is set into motion. This is a good question actually. Now it is saying that after the system is already moved for 2 seconds, somebody just stopped the larger mass, this mass. And just after the stopping of this larger mass, what you can imagine is this string is going to be loose. And because of that looseness, this small t is going to be 0 when somebody just stopped this larger mass. Because the tendency of this whole system, like these masses, is to move here down and here up. So if somebody like hold this up, this one, then this will just go up, but this is just going to be hold, this bigger mass. And because of this, this will keep going up, and thus it will make the string loose. So this is the inference from this question, question number D. So the situation is like this. Initially, the whole system, like both the masses, is moving with acceleration g upon 3. That is approximately 3.26 meters per second square. Before all these things, like before stopping the bigger mass at 2.0 second when the system is set into motion. Okay. So before actually stopping the bigger mass, we need to find the velocity of this first mass, first system, and I'll tell you why. So just by applying v is equal to u plus of at, Newton's first equation of motion, we need to find this v. That will be equal to u is basically 0 plus of acceleration is 3.26 multiplied by 2. That will be equal to 6.52 meters per second in the upward direction. This, the first system. This is just before stopping the bigger mass of 600 gram. Now, when the first mass is moving with this much velocity, somebody just stopped the bigger mass. So now the initial velocity for the first mass will be this from this time onwards. And the acceleration will be what? That will be minus of g, because now only one force is acting on that mass. That will be only g, because tension is 0 now. In this case, tension is 0. So this is the only acceleration. And the third one is v will be equal to 0. Why? Because after somebody stopped the second mass, like the bigger mass, then the initial velocity, I mean at that time the velocity of this smaller mass, system 1, is 6.52. And from there onwards, this system 1 is going to move till its velocity becomes 0. That will be at the highest point. And the time taken by this first system to reach from 6.52 meters per second velocity to the 0 velocity at the highest point is going to be the time elapsed before this string is tight again. And that's what the question is. Just think it very carefully. I am saying that the first mass is moving with 6.52 meters per second velocity just before the bigger mass is going to be stopped. So from there onwards, for the first system, it is going to move again after 6.52 meters per second, because nobody is stopping it. Only the tension is becoming 0 because of the stoppage of bigger mass. And so now the acceleration of the first system is minus g, in the negative direction g, because that is the only force acting on this first system now. So it is going to continue its motion till its velocity becomes 0. But why it will become 0? Because now the acceleration is in the negative direction, opposite direction of the motion. So it will go until its velocity becomes 0. And that is basically the time from 6.52 meter per second to 0 meters per second, which is basically elapsed before this string is tight again. Because after that, this second mass, like bigger mass, is also need that much time to again travel that much distance, which this system 1 already traveled from 6.52 meters per second velocity to 0 velocity. Actually, this first system and this second system, let me draw like this. This is the first system, this is the second system. So this is going from u is equal to 6.52 meters per second to velocity 0, and acceleration is minus g. This is basically will have to go from u is equal to 0 to v is equal to 6.52 meters per second, and acceleration is plus g. And why this 6.52 meters per second? Because it is going to travel the same distance. X is equal to, say, something k. You can actually find from over here. So this is actually traveling this distance, system 1, in the upward direction, but this system 2 has to travel this much distance in the downward direction. And if distance is same, acceleration is same, the magnitude of acceleration, and initial velocity is same, then the final velocity will also be the same. The initial velocity for this case is going to be the final velocity for this case, for the system 2. So both are basically the same case, only initial and final velocities are different because of the direction of acceleration, and that's why this time elapsed is going to be the same when the string is tight again. Like, you just need to calculate this first system from velocity 6.52 meters per second to velocity 0, and that much time is the time elapsed before the string is tight again, because in that time only this system 2 will travel the same distance as covered by this system 1 from, say, point A to point B, and that will be same from point C to point D, like this. AB is equal to CD. Say this system 1 is traveled AB and system 2 is traveled CD. So these two are going to be the same, and that's why these two cases are going to be almost same, like exactly not same but almost same, because the initial and final velocities are different. So you need to map these things inside your mind. Just watch 2-3 more times to get it very clear inside your mind. So now let me actually calculate it. I have now discussed the concept, so now let me actually calculate the time. So the time will be like v is equal to 0 now, u is equal to 6.52 meters per second now, and acceleration is minus of 9.8 meters per second square now. So now applying again the Newton's first equation, v is equal to u plus of at, that is equal to 6.52 minus of 9.8 t, and from here t is what? 2 upon 3 seconds or 0.66 second. That is the answer. So this is all about this video, guys, and this question number D of 3 is a good question. So you need to practice it or just see it once again and try to understand it carefully. So this is all about this video, guys, and in the next series of videos I'm just going to discuss these types of good questions only from the same chapter, that is Newton's laws of motion. So till then, thank you.